Okay, today we are learning about systems of equations as they pertain to Algebra 2 trig. So we created a foldable where we talk about linear equations, so you have a line and a line, quadratic linear equations where you have a parabola and a line, and conic linear equations where we have a circle and a line. And the equation of a line, if you remember from Algebra 1, is y equals mx plus b, which is your slope-intercept form, or ax plus by equals c. Some examples would be like this, y equals 3x plus 6, or 2x minus 4y equals 3. The equation of a parabola we just had in our quadratics unit is y equals ax squared plus bx plus c. And here's an example of that. And the equation of a circle, which we just completed, had our mini quiz yesterday, is x minus h squared plus y minus k squared equals r squared, where the center is at hk and r is the radius. And here's an example of that. I want you to notice that x squared plus y squared equals 36. This is really centered. This is really x minus 0 squared plus y minus 0 squared. So it's centered at 0, 0 with a radius of 6. Now I want you to take notice at how we can tell the difference between all these different types of shapes just based on the equation. I want you to notice that a circle has powers of 2 for the x and the y. A parabola has a power of 2 on the x, but the y is to the first power. And linear, both the x and the y are first power, first degree. So the way we tell the difference, x is to the first power, y is to the first power for linear. X is squared and y is to the first power. And for circles, x is squared and y is squared. Finally, I want to talk about the number of solutions. When lines are parallel, there are no solutions. When a line is actually right on top of the other line, there are infinite number of solutions. And finally, when they intersect, you have one solution. So those are your linear equations. And now when we have our quadratic linear, they could totally miss each other, and you have no real solutions, which means you could have imaginary solutions. They could be tangent, meaning they only touch at one point. That would give you one solution. Or they could intersect twice, giving you two solutions. Finally, the circle and a line could miss each other completely. That would be no solutions. They could be tangent, touch at one point, having one solution. And finally, the line could cut through twice, having two solutions. Example 1. Name each type of equation, then find all solutions for the system of equations. Well, this is linear, because both of them are to the first power. And this is quadratic, because y is to the first power, but x is squared. So always substitute your linear into the quadratic. So we have 3x minus 6, and that will be plugged in for the x right over here. So when we make that substitution, we end up with this equation, 3x minus 6 equals x squared minus x minus 6. And I'm going to solve this like a quadratic because we have x squared. We want to move everything to one side and try to get a 0 on the left. So we're going to subtract 3x, add 6, and we have 0 equals x squared minus 4x. We can factor to solve this. Some people suggested let's use the quadratic formula. I said no, that's overkill. We can factor, we can extract the x, giving us x times x minus 4 equals 0. Now remember that the zero product property states that we set each of these terms equal to 0. Each of these quantities, x equals 0 and x minus 4 equals 0. Therefore, the solution set is 0, 4. We have two x values, and that means we need two corresponding y values to go with it, because remember, the solution is an ordered pair. So because we have two x's, we need two ordered pairs. So let's plug in x equals 0. Let's plug in 0 for x. And I'm going to choose, you can use either equation, but I always use the easier one, which is the linear. So y equals 3 times 0 minus 6, so 3 times 0 is 0, and 0 minus 6 is negative 6. So one of the solutions is 0, negative 6. This is one of the ordered pairs. Now we're going to plug in 4. 4 gets plugged in for x. 3 times 4 is 12, 12 minus 6 is 6, and my other ordered pair is 4, 6. So as you can see, I've already plotted these two ordered pairs, and my linear equation will look something like this, and my parabola, don't judge me for my crooked parabola, but it will look something like this. And as you can see, 2 points of intersection, two ordered pair solutions. Let's take a look at this example. Here we have a circle and a line. So I'm going to solve for the x. I'm going to choose to use the second equation because it's easier. The linear is always easier. So we're going to isolate the x, and we're going to take y plus 8, and we're going to substitute that in for the x. So what I have is I've rewritten this circle, the circle equation with a large empty parentheses squared, so that when I make the substitution, I don't forget that I must square this binomial, which means I must FOIL. That's the biggest mistake. You must FOIL this, giving you y squared plus 16y plus 64. And the rest drops down. We're going to combine like terms. This is going to cancel each other out nicely because y squared minus y squared is 0. And then we have this simple equation to solve. Subtract 64 from both sides, divide both sides by 16, and y equals 5. So as you can see, this is only going to result in one ordered pair. We're going to take y equals 5 and plug it back in to the linear equation. And I'm going to plug it back into the one that I rearranged. And our solution, x equals 13, will go with our ordered pair, so the final answer is 13, 5. Okay, here's a good one. Name each type of equation. Well, we have x squared plus y squared equals 4, that's a circle, and y equals x is a line. If these equations are drawn on the same set of axes, what is the total number of points of intersection? Well, we don't have to do any algebra. We know that y equals x is this line. It's the diagonal line. Because if x is 3, then y is 3, right? If x is 4, then y is 4. If x is 0, then y is 0. In other words, these are all the points for this equation. That's why we have this diagonal line that goes this way. And we know that our radius of the circle is going to be 2, centered at 0, 0. So I've already drawn the circle. I'm just going to bring it over here and show you that it fits right in there. Right? Radius is 2. And we have 2 points of intersection. So the answer to this question is 2. But what if we were to extend this and say, look, I want to find out what the ordered pairs are, or what are the x values? Well, it looks like it falls between 1 and 2, but I want to know exactly what it is. So what we could do is we could substitute and solve algebraically. So we'll take y equals x, we'll take x, we'll plug it in for y. So we end up with x squared plus blank squared equals 4. Now what goes in for this blank? Well, y gets substituted with x. So x squared plus x squared equals 4. Combine like terms. 2x squared equals 4. Divide both sides by 2. X squared equals 2. And finally, we take the square root of both sides. X equals radical 2. Now, radical 2, when we plug this into our calculator, we end up with 1.41 and some change. And this is pretty darn close to what we estimated here when we said it fell between 1 and 2, somewhere closer to the middle, so 1.5. But 1.41 is our decimal approximation. But I thought there was also going to be a negative 1.41. Well, there is, because of the plus minus cases whenever we take the square root. So radical, remember that's why we do the plus minus, so there's actually two solutions, positive 1.41 and negative 1.41. And there you have it. It's a bit of a lengthy lesson, but very important. Best of luck to you.